Picture this, it's early in the morning, you open your phone and scroll through the news, and within seconds, you're hit with a wall of headlines. One says that the economy is booming, another says it's collapsing. One article sounds optimistic, another article sounds like the world is ending. And somewhere in between, there's that lingering question: what's actually true? That confusion, that noise, is exactly why this project exists. This isn't just another news app. It is an AI powered news intelligence engine designed to cut through the chaos and give you something that traditional news platforms don't: clarity, context, and confidence. Now, imagine a different experience. Instead of reading 10 long articles, you open the app and instantly get a clean 3 line summary of each story. No bluff, no clickbait, just the core information. This alone saves time. But this system goes much deeper. Next to every article, you see a sentiment score. Is the article written in positive tone, neutral, or negative? This matters more than you think. News isn't just about facts, it's about how those facts are presented. With sentiment analysis, you began to notice patterns: which sources are dramatic, which are balanced, and which are slowly influencing your perception. But here's where it gets really interesting. Each article also comes with a fake probability score. Now, this isn't just a magic lie detector, but it's a powerful AI driven estimate based on language patterns, tone, and context. It flags articles that might be misleading. Instead of blindly trusting everything, you now have a second layer of verification, and that changes everything. But the system doesn't stop at individual articles. It starts by connecting the dots. Using clustering algorithms, it groups similar news stories together. So instead of scattered information or headlines, you begin to see themes. What's actually happening in the world, not just isolated events. Politics, tech, global crisis, they naturally organize themselves. On top of that, the system highlights trending keywords, not based on hype, but based on real frequency, across multiple articles. This gives you a quick snapshot of what the world is collectively talking about right now. So, what does the user actually get from all of this? You get time efficiency, summarizing instead of long reading, emotional awareness, sentiment insights, credibility signals, fake news probability, structured understanding, clustering of topics, big picture trends, keyword analysis. In simple terms, you are no longer just reading news, you are understanding it. And that's the real purpose of this project. We are living in an era of information overload, where the challenge is no longer to access the information but to filter it. Anyone can publish anything. Headlines are optimized for clicks and not truth. Bias is subtle, misinformation spread fast, and attention spans are shrinking. This system acts like a personal AI analyst. It doesn't replace journalism, it enhances your ability to interpret that information. It gives you tools to think critically, spot patterns, and make informed decisions. So, next time you open a news app, ask yourself, do you want more information or do you want accurate information? Because that's the gap this project is built to fill. And before we move forward, there's something important to say because it keeps the project grounded in reality. This system is powerful, but it's not perfect. The fake news detection isn't guaranteed truth engine. The sentiment analysis can sometimes misinterpret tone. The clustering might group particles in ways that aren't always intuitive. And since it relies heavily on large language models, the output depends on prompts and external APIs, which means there can be inconsistencies. In simple terms, this is not a finished product, it's a foundation. Think of it like a starting point for building an intelligent news system, not the final destination. So, if you are watching this as a developer, data scientist, or a student, don't just use this project. Build on it, break it, improve it, make it yours. Because the real goal here is not just to consume AI, but to learn how to create it. In the next part of the video, we'll dive deep into how this entire fake news detection system works from inside out using this flowchart as a roadmap. We'll break down every stage step by step, from fetching the real-time news articles to AI-powered summarization, sentiment analysis, fake news detection, clustering, and trend analysis in a simple and easy to understand way. Then, in the third part of the video, we'll move into the practical implementation side of this project. We'll set up the required APIs, configure the environment, and go through the complete code explanation line by line so you can fully understand how everything connects together behind the scenes. As you have seen in the first video where I demonstrated our AI-powered fake news detector, you may have noticed that this project is little different from the typical fake news detection projects you see on other YouTube videos. Usually, many data science tutorials use old pre-level datasets that are already divided into fake and real news, and they train a machine learning model on that limited data. While that's great for learning ML concepts, it often doesn't reflect how news behaves in real world. Real news is dynamic, messy, emotionally biased, and constantly changing. So, I wanted to build something more practical and closer to reality. Instead of depending only on static datasets, this project fetches live news articles in real time and analyzes them using modern AI techniques like large language models, sentiment analysis, fake news probability estimation, topic clustering, and trend detection. If you haven't watched the first part of this series yet, I recommend checking that out first because that's where I showed the live demo of this project. But in today's video, we'll go much deeper and understand the complete system design for this fake news detector using this flowchart. Imagine you open an app and ask what's happening in the news today. That simple request kicks off a smart pipeline behind the scenes. First, the system receives your request and quickly fetches the latest article from the news API. It then extracts the important parts like the title and the description, so it knows what each article is about. Next comes the intelligent layer. The system uses AI to create a short summary, so you don't have to read the long articles. At the same time, it checks the tone of the news through sentiment analysis, whether it's positive, negative, or neutral. Most importantly, it runs a fake news detection model to estimate how trustworthy each model is. All this process information, summary, sentiment, and trust score is combined into a clean dataset. Then, the system organizes articles using techniques like TF-IDF and clustering, grouping similar topics together. It also identifies trending themes by analyzing frequently used words. Finally, everything is packaged into a neat JSON response and sent back to you. Instead of raw news, you get clear, summarized, organized, and credibly checked information, helping you understand the world faster and smarter. Now that you have got a rough idea of how the system works, let's dig deeper and understand how each of the elements in the system works. So let's start with the user request API, also known as the entry point of the system. Imagine a user opens your app and clicks show me the top news. Behind the scenes, that simple action triggers a request to your backend API endpoint like API top news. This is where your system's journey began. This request is handled by the fast API server, which acts as a central controller of the entire pipeline. FastAPI parses query parameters such as country, category, or a search keyword like Q. These parameters define what type of news the user is interested in. At this stage, no machine learning happens yet. This is more about API design and request routing. But it's a critical part of any machine learning system because it connects the user to your intelligent engine. Technically, FastAPI uses asynchronous function to ensure high performance. This ensures multiple users can hit the API simultaneously without blocking the server. This is especially important because downstream tasks like LLM calls and API fetching can be slow. Think of this step as the director of a movie. It doesn't act itself, but tells other components what to do next. It validates the inputs, ensures everything is structured correctly, and then forwards the request to the next stage, fetching real world data. From a system design perspective, this is your serving layer, the interface between user and your ML pipeline. If this layer is slow or poorly designed, even the best ML models won't matter. Now let's look at Fetch News API, also known as the data ingestion layer. Now that the system knows what the user wants, it moves to the data collection phase. This step uses an external service, the News API, to fetch real-time articles. Think of it like sending a reporter out into the world to gather fresh information. This system constructs an HTTP request using parameters like country or keyword and sends it using an asynchronous HTTP client. Because it's asynchronous, the system doesn't just sit idle waiting for a response. It can handle other tasks in parallel. This is crucial for scaling in production systems. Once the API responds, you receive structured JSON data containing multiple articles. Each article typically includes fields like title, description, context, URL, and source. However, raw API data is often messy or inconsistent, so this stage also acts as the data ingestion and normalization layer. From an ML pipeline perspective, this is your data source. Without high quality input data, even the best models will produce poor results. This is why error handling is included. If the API fails, the system raises an exception to avoid propagating bad data downstream. You can think of this step as the data pipeline entry point in MLOps. It ensures that your system is always working with fresh, relevant, and structured data before any neural language processing or machine learning processing began. Now, let's look at article content, also known as the pre-processing stage. Once the articles are fetched, the system extracts the meaningful textual content, primarily the title and the description. This might seem simple, but it's actually a crucial pre-processing step in any neural language processing pipeline. Not all articles come with complete data. Some have missing descriptions or gibberish content. So the system uses a fallback strategy. It tries description, then content, and defaults to a empty string if nothing is available. This ensures robustness and prevents failure in downstream tasks. At this stage, the text is still unstructured raw data. No machine learning has been applied yet. However, this step prepares the data for natural language processing tasks by ensuring consistency in input format. You can think of this as data cleaning and pre-processing, a fundamental concept in machine learning. Before feeding text into model, whether LLMs or vectorizers, you need to standardize it. This stage also sets up parallel processing. For each article, a task is created to process it independently. This allows the system to scale efficiently when dealing with multiple articles. This is like organizing raw notes before writing a report. You are not analyzing it, just making sure everything is readable, consistent, and ready for intelligent processing. Now, let's look at the most important part of our system design: summarization, sentiment, and fake news detection, also known as the intelligence layer. This is where the real AI magic happens. Each article is sent to a large language model via API, and three tasks are performed simultaneously: summarization, sentiment analysis, and fake news detection. Instead of training models yourself, you use a zero shot learning through prompt engineering. You provide clear instructions in the prompt, and the LLM generates structured outputs. For example, sentiment analysis returns a label positive, negative, or neutral, and a confidence score. All three tasks run concurrently using asynchronous gather function, which significantly improves performance. This is a practical example of parallel inference in ML system. Technically, this system leverages natural language processing, pre-trained transformer model, prompt engineering, and API based inference. This layer transforms raw text into structured intelligence. Summary, which condenses the information, sentiment, which tells us about the emotional tone, and fake news probability, which tells us the credibility estimate. Think of this as your system's AI brain. It interprets, analyzes, and enriches the data. Without this step, your system would just display raw news. With it, you will be provided with insights. Now, let's look at processed articles, also known as the feature enriched data. After the LLM finishes processing, each article is transformed into a structured object containing enriched features like title, summary, sentiment, and fake news probability along with its source. This is a critical transition point. Your data is no longer raw text, but feature enriched structured data ready for future machine learning tasks. In machine learning terminology, this is similar to feature engineering output. You have taken unstructured input and converted it into meaningful attributes that can be used for clustering and analysis. This step also ensures consistency. Even if the LLM fails, fallback values are provided, making the system robust. Think of this as assembling a clean dataset with each row or article has all the necessary columns or features. This structured format is essential for the next steps like vectorization and clustering. Now let's look at TF-IDF vectorization, also known as converting text to numbers. Now comes a classic ML step, converting text to numbers. Machine learning models cannot understand raw text, so you use TF-IDF or term frequency inverse document frequency to represent each article summary into a numerical vector. TF-IDF works by assigning weights to words. High weight meaning important and unique words. Low weight meaning common words like the or is. This creates a matrix where each article is represented as a vector in high dimensional space. This is known as feature extraction in neural language processing. Technically, input refers to the list of summaries and output refers to the sparse matrix of numerical features. This step is crucial for clustering because algorithms like K-means rely on numerical input. Think of this as translating human language into language machines understand. Now let's look at K-means clustering. Over here we use it for topic detection. With numerical vectors ready, the system applies K-means clustering, an unsupervised learning algorithm. It groups similar articles based on their content. K-means works by choosing a K cluster, here 3, assigning articles to nearest cluster centroid, updating centroids iteratively. The result is that similar news articles, for example, politics or sports, naturally group together. This is called unsupervised learning because there are no labels. The algorithm discovers patterns on its own. Each article gets a topic cluster ID, which helps users understand related news. Think of this as organizing a messy library into categories without prior labels. Now let's look at one of our last step but not the final step, which is trend detection, also known as keyword extraction. What it means is that the system identifies trending topics using simple frequency analysis. It extracts words from the titles and counts them, often they appear using a counter. This is not deep ML but falls under statistical neural language processing. The idea is simple. More frequent words, meaning trending topics, short or irrelevant words are filtered out to improve quality. This step provides quick insights into what's currently popular in the news. Now we have come to the final step of our system design, which is known as the JSON response or the output layer. Finally, everything is packaged into a JSON response and sent back to the user. This includes the processed articles, clustered labels, trending keywords, and timestamp. This is the output layer of your ML system, where insights are delivered in a structured format. Think of this as the final report generated after all the analysis is complete. So that was the complete system design of our AI-powered fake news detection engine. We explored how the system fetches live news data, uses large language models for summarization and sentiment analysis, estimate misinformation risk, performs neural language processing based topic clustering, and finally transforms raw articles into meaningful intelligence. Now, this project is still a foundational version and there's a lot of room for improvement. You can experiment with better models, embedding vector databases and custom trained classifiers, or even build your own real time AI news monitoring platform on top of this idea. But the main goal of this project was not to build another ML model. It was to understand how modern AI systems are designed and connected together in real world applications. And in the next part of this series, we'll move from system design to actual implementation. We'll set up the complete project from scratch and go through the code line by line so you can fully understand how every component works internally. So, if you enjoyed this video and learned something new, make sure to subscribe to the channel and like the video and turn on the notification so you don't miss part 3. Thanks for watching and I will see you in the next one. Now comes the most exciting part of the entire project, the moment where we actually bring this AI newsroom to life using code. Till now, we have understood the vision and the architecture behind our fake news detection system. We saw that how the front end talks to the back end, how the AI models analyzes articles, and how machine learning helps detect patterns inside the news. But here's where things get really interesting. What if I told you that with just a single search, our system can fetch real time articles from the internet, summarize them using AI, detect emotional tone, estimate fake news probability, and identify trending topics, and even compare political bias perspective, all automatically within seconds. And the crazy part, every feature is connected together like an intelligent digital newsroom operating in real time. So, in this part of the video, we are not just reading code line by line, we are going to understand the story behind the code, why each block exists, how different components communicate, and how asynchronous AI processing makes this system fast, and how machine learning and LLMs combine together to create an actual AI powered media intelligence engine. We will start with importing all the required libraries. Import OS, import JSON, import asynchronous IO. From typing import list dictionary, from collections import counter, from date and time import date and time. This is the foundation stage of the entire project. Before building an intelligent fake news detection system, the application first gathers all the tools it needs. You can imagine this part like assembling an highly skilled newsroom team before starting operations. Every imported library has a specific responsibility inside the project. Fast API is responsible for building the backend server that users will interact with. HTTPX helps fetch the live news articles from the internet. OpenAI is used to communicate with powerful AI models hosted on Gork. Asynchronous IO helps the system perform multiple AI tasks simultaneously, making the application much faster. Then, machine learning libraries like TF-IDF Vectorizer and KMeans are imported to help the system understand text patterns and automatically group similar news topics together. Overall, this block prepares the AI newsroom with everything required for backend development: machine learning, neural language processing, asynchronous execution, and API communication.
Storms on the roof.
Now we will focus on loading the secret API keys. In this project, the fake news detection system depends heavily on two external platforms. The first is the News API, which provides real-time news articles from across the world. The second is Gorg, which provides access to the powerful large language models that perform summarization, fake news analysis, and sentiment detection. Instead of directly writing secret API keys inside the code, the project stores them safely inside an environment file. This is professional software engineering practice because API keys should never be exposed publicly. The application then checks whether both keys are actually available. If one of them is missing, the system immediately stops executing because the project cannot function properly without these services. This prevents the backend from running in a broken or incomplete state.
Sun is falling, speed in the black. Nobody driving, we're in the back to the end of the world.
Now we will be connecting the project to AI models. At this stage, the application connects itself to multiple AI models. This is where the intelligence of the fake news detection system truly begins. Instead of depending on a single AI model, the project creates a list of multiple models that can act as a backup for each other. This is an advanced production level engineering technique. If one model becomes slow or unavailable or fails to generate a response, the system can automatically switch to another model without the user even noticing. It is similar to having multiple expert journalists available in a newsroom. If one reporter is unavailable, another immediately continues the investigation. This design makes the application more reliable, stable, and fault tolerant. The connection to Gork also ensures extremely fast AI response, which improves user experience significantly. Now that we have connected the project to AI models, we will be creating the Fast API backend server. Fast API acts as the headquarters of the entire fake news detection system. This server will receive requests from users, process them using AI and machine learning, and send intelligent responses back to the front-end interface. Then comes an extremely important configuration called CORS middleware. Normally, browsers block communication between different domains for security reasons. However, front-end applications often run on different ports or domains during development. By enabling CORS will allow origins, the backend allows any front-end application to communicate with it freely. This makes front-end backend integration much smoother during development and testing. Now we will be connecting the front-end files. This section connects the visual front-end interface of the project with the backend server. The backend now knows where the HTML, CSS, JavaScript, and the file images are stored. The static folder usually contains styling files, scripts, icons, and front-end assets, while the templates folder contains the HTML pages like the home page. Without this setup, the backend would only function as an API service with no visual interface. This block essentially gives the project a face that users can interact with through a browser. It transforms the project from a pure backend engine into a complete web application.
Sun is falling, speed in the black. Nobody driving, we're in the back
Now that all of this is done, we'll be now creating a AI fallback engine. This is one of the smartest engineering sections in the entire project. This function acts like a central AI communication manager that handles all the interactions with the large language models. Whenever the application needs to summarize news, analyze sentiment, or detect fake news, it sends prompts through this function. This function loops through all available AI models one by one. If the first model fails, the system quickly moves to the next one. This creates a robust fallback mechanism that prevents the application from crashing during failures. The user experiences smooth operation because the backend intelligently handles errors internally. This is very professional backend architecture approach commonly used in real-world AI application. Now we want to perform sentiment analysis on our news articles. This section gives the application emotional understanding capabilities. This system acts as the AI model to study the tone of the news articles and classify whether it's positive, neutral, or negative. For example, news about war, disasters, or economic collapse would likely be classified as negative, while news about scientific breakthroughs or economic growth might be positive. The AI also provides a confidence score between 0 and 1. A higher score means the model is more confident about its prediction. The project specifically requests the response in JSON format because the structured data is much easier for backend systems to process reliably. Now we will be cleaning and returning the sentiment results. After receiving the AI response, the system carefully cleans the output. Sometimes AI models wrap JSON responses inside markdown code blocks like JSON. These extra symbols can break JSON parsing. Therefore, the project removes these unnecessary characters before converting the response into a Python dictionary. If anything goes wrong during the parsing, the application safely returns a default neutral sentiment score instead of crashing. This error handling strategy makes the backend much more stable and production ready. Now, we'll be working on the fake news detection engine. This is the core intelligent feature of the project. Here, the AI is asked to behave like a digital fact checking analyst. The system provides the news articles to the AI and asks it to estimate the probability that the content may contain misinformation, exaggeration, propaganda, or suspicious claims. The AI returns two important outputs: a fake probability score and a short explanation describing why the articles appear suspicious. This does not guarantee whether the news is absolutely true or false. Instead, it estimates the misinformation risk based on language patterns, sensational wording, unsupported claims, and emotional manipulation, and inconsistencies found in the text. Now, we will be summarizing the news articles. Modern news articles are often very long and difficult to read quickly. This function solves the problem by asking the AI to generate a short, neutral summary of the article in just 3 sentences. The word neutral is extremely important because the goal is to provide factual summaries without emotional or political bias. Instead of forcing user to read the entire article, the application extracts only the most important information. This improves readability, user engagement, and overall user experience significantly. Now we'll be fetching the real-time news from the internet. To do so, we'll be using the code async-def fetch news country, category, and queue. This function acts like the live news collector of the application. Depending on what the user requests, the backend fetches the real-time articles from the news API. If the user searches for a specific keyword, the system uses the everything endpoint to search globally. Otherwise, it fetches the top headlines based on country or category. This flexibility allows users to explore news dynamically. The function also uses asynchronous networking through HTTPX asynchronous client, allowing the backend to fetch data efficiently without blocking other operations. Now we'll be looking at how to detect the trending topics. This function helps the system identify trending discussions across multiple news articles. The application collects all articles, titles, breaks them into words, and counts how frequently each word appears. Words that repeatedly appear across many headlines are considered trending keywords. Now, we'll be clustering the topics using machine learning. This section introduces machine learning intelligence into the project. Computers cannot directly understand raw human language, so the system first converts the article summaries into numerical vectors using TF-IDF vectorization. Now, let's connect the home page. This section connects the backend server to the front-end web page. When users open the website in their browser, Fast API serves the index.html file stored inside the templates dictionary. This allows users to visually interact with the fake news detection platform through a graphical interface rather than directly calling the API manually. This saves developers from manually restarting the application repeatedly while building and testing features. Alright, I hope that now you have got a complete understanding of how the fake news detection system works. Before you go, if you enjoyed this video and learned something new, make sure to subscribe to the channel. It really helps me bring more AI and machine learning projects like this for you. And don't forget to like this video and share it with your friends.